Okay, so when you open the software, this is the image that you may have. You may have this space a little bit bigger. And then you have 4 options here on the left side. We're not going to use in general the interface because it's for making our model more attractive. We're going to use map, model, and equation. So for map, will be used for constructing your stock and flow diagram. Here you have the same things that I mentioned to you during the lecture. So this is the stock, the squares are the stocks, and these ones are flows. This area define the boundary, and if you put the flow outside the stock, it will also show you another cloud because it means that it's not inside the stock. So these are stocks flowing in and stocks flowing out. And I'm just going to put it very simple at this point. So this is how you make your stock and flow diagram. And then when you click on model, question marks will appear on your stock and flow diagram. This is because you need to ask values. For the stocks, you need to have the initial value. If you double click here, this window appears, and this is where you have to put values, the initial values. You can also put units here, but not all units are available. So that's why there is no obligation of putting the units as long as you keep consistency on your units in your flow, stock and flow diagram. So once you put a value, then you can click here for OK. And then the question mark have disappeared because it already has a value. For the flows, if the flows are, they don't have any converter connected to it, they will appear, they will ask you also for values. If you have flows, which are actually, it can be equations, if you have converters affecting the flow, like this, and how do I delete something? Okay, let me go to that question. It says, how do you delete something you have drawn? Okay. I think what if I click here on the beginning of the arrow and I click delete, it goes away. Same for flows. You just have to delete like this. All right. So I'm going to continue now. So you can add arrows to the flows, and these arrows imply that this flow has to be constructed with an equation involving the stock, in this case, and the converter, right? Because I put arrows into this flow. So if we're talking here, the simple example, which is in population, and this births, and this birth rate, then we need to give a value. For converters who don't have arrows from anywhere, you need to add a specific value. So we can have 0.5, let's say. And then now, for constructing the equation here, you need to click on the required inputs, okay? So in this case, I click on bit rate, and I will multiply the bit rate times the population, and then I will click OK. But before clicking OK, I'm going to show you some of other features of this constructing equations. You also have a list of options here, as you have in, like, for instance, if, logarithm, other things that you can use. And then we will also be using these mathematical features. We also can have the option to have an uniflow, that so the flow is in this direction, so it is a positive flow, or we can have a biflow, and that will mean that this can go in both directions. And probably this is defined by, this will be defined by the equation. At this point, we will use only one flow. And then we click OK. This sign appears sometimes when there is a value that that maybe I think maybe I run the model and I check why, but sometimes this sign appears on the stocks. Shouldn't be a problem. So now we have everything in our model, in our simple model, to run it, okay, and to get a result. Before going to the result, I'm going to show you the equation section. So in the equation section, you can see the equations that have been constructed, which are called stock flow equations. So you have the population which is the stock, and the change in population over time will be equal to the previous time, population at the previous time, plus the flow of birds multiplied by a time step. And then it shows you also the equation of the inflow, and any variable, and any value that we have given for converters, okay? Are there any questions at this point? No questions? Okay, so I'm going to continue. Okay, so now we go to the top part of the software, and we have file, edit, view, model, run, and help. So to run the model, we click on run, but before running, we're going to check run specs. Run specs will tell you the time of the simulation, the time that you want to simulate. Remember that flows have units of time, okay? So we, in this case, maybe a number of people per year, for instance. So if all units are per year, we're running the model from 0 to a certain number of years, okay? And then we can say here that I'm using years, but if the units, if we're using minutes, for instance, and the units of time are not here, we can just click other. Run specs also tells you the time step. So it means how are we going to divide the whole length of time in order to calculate to solve the differential equation that we have. that we have constructed. We also have the option to decide the integration method that we use, that we later on our lectures we will discuss, and also the simulation speed. In this case, we have that 0.1 real seconds equals to 1 unit of time, okay? That means that the model will, our model will run for 10 seconds. So then I click now run here. And it starts running. To see the results, we have two options here. We can either see the results as table or as a graphic. I'm going to show you now a graphic. So I click here. I'm going to do it again. So I drag here. I took a graph from here or a table. And then I do double click on the graph. I do double click again, and then all variables that I have in my model will appear. And I get to decide what I want to see on the graphic. So I decided to have population. And this is how my, my model look like. And this is what is called an exponential behavior, because it will continuously increase, right? If we have now, if we add a flow out, like for instance, deaths, and we give them a value, like well, now we're saying per year, we just decided to have per year, but if we have one person per year who died, because I only had 10 people here, oh, I have 100. Okay, so now I run my model again. And you will see that the system will behave different now. Still is an exponential. I may need to make this a little bit bigger. Oh, okay. Or maybe what I can do is to have it dependent on the population and also on the death rate. So I run my model again. And now I can see my result. There is a way to, we can see, as I said to you before, on a table, we can see our results. And you can see how the population is being increased. Okay, so this increase is higher, is always increasing, probably because the death rate is way much smaller than the birth rate that I have just put. So to, if you want to export the results, you also have an option for export data. So you can export the data, and I can have the option of only exporting the values that I have put on table 1. I need to find this destination. in Excel. So I need to make a file in Excel to have a destination, and then I click OK, and then I can export the data. I have a question now. It says, can you please show you define death rate? Yes. So I put as death rate 0.1 only. Was that your question? Okay. And my birth rate is 0.5. Now I have moved to 0.6, the death rate. And now instead of having an increase in population, I am decreasing the population because the death rate is higher than the birth rate, okay? No, the death, I have a question here that says if the death was just one. But no, the death now is constructed by the equation that I have to make, which is population times the death rate. So now I don't have a fixed value anymore. I had to construct an equation for the flow.